Alrighty, excuse me. Hello, good morning, welcome here. Friday. Electrical energy and power plants. Make sure you get all the details, the symbols, the cooling towers, the cars in the parking lot, get license plates. This is the unit we're on, electrical energy and power plants. Okay, you copied that down. Mechanical, thermal, and radiant energy are transformed into electrical energy in power plants. This is sun, heat. This could be a variety of different things. Lots of times, like thermal works with mechanical. The heat, steam rises and moves turbines and different things like that. Electrical power is the rate at which electrical energy is generated or transformed, which is expressed in watts. And a watt is equal to a joule per second. Okay, so power is energy over time, joule per second. Electrical energy is measured in kilowatt hours. And what that means is, like, if this is joules per second, if it's kilowatt hours, then the watts need to be changed to kilowatts, and time would then be hours if we're talking kilowatt hours. Megawatt hours for power plants. Mega is a million. Okay. All right. I don't need to read all of this to you, but this part here, it says if no more electricity can be generated, more needs to be purchased elsewhere. With all our kind of rivers and lakes, that's like so much of our power is generated by water. There was but like there's routine that, people saying, use less power, so on and so forth. Cynical people would comment the reason why Manitoba wants, I shouldn't say cynical, maybe they know more than I do, but it just sounds cynical. They'll say that the reason that Hydro wants people to use less, because if people in Manitoba use less, then Manitoba Hydro makes less. And so some people would point out, well, they're not saying, use less, be responsible. They just want to be able to sell more, power to communities nearby, including the States. There are people like we get a lot of it from water. There's places in the world where they burn garbage. Some cities are powered by burning coal. So, anyways, when it says there's no practical way to store electricity, it means kind of in the long term. Like we can't. It's hard to kind of save up energy. Oh, this energy here will last us for a year. Electrically, it's really hard to do. And there you go. I'm gonna look at the tutorials with you. All right, I should also save this. Just about blah blah blah. Anyways, I don't need to share every single thought I have. Okay, let's reorient. Okay, so we're gonna do tutorial 1. No, we're not. We're gonna do practice 1 on page 505. P1, page 505. Should still be in focus. All right. So it says, what is the power rating of a digital camera that transforms 120 joules in 25 seconds? Okay, so our formula is P equals E over T, right? So this is watts equals joules over seconds. P in this case is what we want to solve for. P equals the energy we're given is 120 joules, and the time is 25. So 120 divided by 25. Calculator out. I feel like I should be able to do this. That's 4.8. 120 divided by 25, 4.8. So power equals 4.8 joules per second, or watts. Okay? Watts would be the preferred term. So for practice 2, that one took a lot of work, hey? Kind of nice change. It says, how much power does a hairdryer require to transform 198,000 joules of energy in 15 minutes? Okay, so power equals 198,000. It says over 15 minutes. 15 minutes. Somebody just knock on my door. Somebody just knock on the door? They just walk from the back. Oh, okay. So 15 minutes times 60 seconds. Right? Because it needs to be in seconds. Time is in seconds. So if you're given minutes, you got to convert it to seconds. So 198,000 divided by 15 equals that. Divided by 60 is 220. 220 watts. Can you dig it? Nothing too crazy to start out, hey? Nothing too crazy. We're going to skip ahead to, oh, was that it for, oh no, there we go. Practice 1 on page 506. Says, a compact fluorescent light bulb operates with 7 watts of power. Calculate the energy it needs to provide light for 24 hours. Now, it says answer in joules, so no kilojoules or kilowatt hours. Now, normally I would write down the equation every time, but still sitting here, it's still visible. So P, power is 7. We need to figure out the energy, and it's 24 hours. Now, 24 hours, there's 60 minutes in an hour, and then 60 seconds in a minute, right? So this is, we need to figure out the seconds and then solve. So we multiply everything by all this, which just basically means 7 times 24 times 60 times 60. 7 times 24 times 60 times 60. So that's 604,800. Now this is 2 sig figs. I can't remember, is that 7 or 7.0? Yeah, 2 sig figs. So easiest way to do this would be a scientific notation. 6.0 times 1, 2, 3, 4, 5 times 10 to the 5 joules. They want it in joules, right? Yeah. Last one. Practice 2, page 506. Convert your answer in question 1 to kilowatt hours. Okay, so we're going to change this to kilowatt hours. Well, what we can do, change this to kilowatts and this to hours. Okay, so first of all, 7 watts equals, so basically we just divide this by 1,000, so it's 0.007 kilowatts. If it helps, think of it like anytime you see the kilo, it's like, oh, how does that work? Think of it as meters. If we had 7 meters, that would be 0.007 kilometers, because there's 1,000 meters in a kilometer. Okay? And then it's kilowatt hours, so we can just leave the 24. Kilowatt hours, yeah, 24 hours. So we reset up the question, so 0.007 equals E over 24. Multiply both sides by 24. 24 times 0.007 is 0.168 equals 0.168. Yeah, it was 2 sig figs, so that's 0.17 kilowatt hours. Star checks out. Can you dig it? 1 to 5, page 507. Enjoy. This is a long lesson, eh?